Hi everyone and welcome to Docker Compose tutorial from Indureka. So my name is Neeraj Kheria, and before we start our discussion on Docker Compose, let's discuss the agenda for this entire module. So first of all, we are going to understand what exactly Docker is, why we are going to use Docker Compose, why it is most popularly used as one of the Docker management tool, and what exactly Docker Compose is, how we can install Docker Compose on different platforms. So here we are going to look at Windows, Linux, and Mac systems, depending upon the system level that you have. And then we are going to see a hands-on on Docker Compose, how we can deploy the application and how we can work with the microservices as a part of a hands-on in this entire discussion. So let's start with our discussion on Docker. So Docker is one of the most popular containerization tool available, where it is used to design, deploy, and run applications by using the containers. Now, when we talk about containers, and containers are the individual environments, or we can say complete isolated environment in which we package the application code and all the bins and libraries that are required to run it. So if we compare the container with the actual VMs, then when we are sharing the image for any VMs so that the operations team can execute the entire application in the same environment, that VM contains the entire host operating system, and that itself makes the entire image larger, and we can say almost 1 to 2 GB or 3 GB in size. And that is not a feasible task to share that image file with anyone, and again it becomes a difficult task even for the operations team to continuously keep downloading those heavy VMs and deploy it on the systems, right? So there has to be a good solution for it, and that exactly is offered by containers. And Docker is one of the most popular containerization tool available, where we can use this platform for creating containers. And because of its popularity, because of the ease and method through which we can create containers, we can easily create containers, we can easily package the entire application with all of its dependencies. That's why Docker is preferred by majority of the DevOps engineers all around the globe. Even multiple other platforms, like we have the continuous integration tools, like we have Jenkins, again they support Docker on each and every level, and that's why it is easily accepted. So that's why if we have containers built on Dockers, it is easily accepted by other platforms when we're talking about the entire DevOps lifecycle. And that's what makes Docker the most popular tool available for creating the containers. So if you talk about containers, again, containers, they contain the applications and all the bins and libraries, as we discussed, for running the application. And these containers are then deployed on the Docker engine and the host operating system, which are required to run it. Now, for creating Docker containers, we do need to have the entire Docker file deployed. First of all, we have to create a Docker file where we can define how exactly the entire image has to be created. So basically, if we are building any application where we need to package, let's say, any particular Apache server, or if we have the application code that needs to be created, so we have to create a Docker file for it, which contains the entire project code. And then we can create an image out of it. And then from that image, the containers are going to be deployed. And then the image itself is going to be deployed and stored in a centralized repository like we have Docker Hub. So now when we talk about a centralized repository, that means just like we have GitHub. So GitHub is what? GitHub is also one of the centralized remote repositories where we can allow the developers coming in from different locations, and they can continuously update and push their code in this repository that can be shared by anyone. And Docker file and the Docker image, which is being stored in Docker Hub, that is going to be created by Docker file. And if you want to make any changes, then we have to make those changes in the entire project in Docker file itself. So once an image is created out of that Docker file, we cannot make changes to that image directly. So we have to make the changes to Docker file, and then we can use the Docker file to create the image with the changes that has been applied. And that image can be used for creating the containers. And if you want, we can push the images to Docker Hub. This can be deployed on the staging servers and production servers, depending upon the setup. And that's why they allow to package any applications with all the part of it needs, such as libraries and other dependencies, and deploying it as one single package. And that's why they are considered as lightweight alternatives to virtual machines and use the host operating systems. Next, we are going to discuss on why Docker Compose. So when we have a single container, we don't need any specific tools to manage that container. We can do that ourselves, right? But when we have large number of containers that have been deployed, so managing those large number of containers manually is not going to be an easy task, or it's not going to be feasible at all. So for managing those large number of containers, we have to use a tool which is going to allow us to manage those containers, to deploy those containers, to simply, if we want to scale up the containers, if we want to add more containers, if we want to remove some containers, we have to deploy the containers, we have to deploy the updates in those containers. So for every setup required, every kind of management tool is offered under orchestration tool like we have Docker Compose. So if we talk about a simple example, we can take the example for Agio, which is basically one of the most popular online retail store. So Agio is basically deployed again in different services. So basically Agio in, or even if you talk about any e-commerce store, not just Agio, but any e-commerce store, they have multiple components, as in multiple microservices defined here. So for example, Agio being an online e-commerce store, it has a component for server, where it allows the users to log in or sign up for a new account. Then it has a different service for catalog, where the users can browse through the entire product. And then we have the shopping cart, which is again offered as a service, where the users can keep the products that they like, they are, or they would like to check out with. And then we have other service for checking out, which is integrated with any of the popular online payment gateways. Now, these all services are deployed separately. They are not deployed on a single server, but they're not bundled together, because if we do that and if we have bundled them all together, and if we have any issues in any single component, then that is going to create issue for the other components as well. That means in case there's an issue with the catalog, then the login account server, the shopping cart, these checkout, again, these functionalities are also going to be hampered. If there's some issue with the checkout, then all the other services are also going to be hampered. Because even if there's something wrong with only one service, then still, so for example, if there's something wrong with the checkout, still the users can create their account, they can browse through the entire product, they can add them to the cart, but they won't be able to check out for a certain time period till the time the developers team, they fix the issue. That means at least all the other components will be up and running without any issues. And that's why it is always a better method to go for medium to large scale applications, where we can define the entire services into microservices. So basically, we have a complete service together offered as an online retail store. And then here we are dividing the entire services into multiple microservices component, where the login account can have access to their own database for accounts, where catalog can have its own data set, data access to any database defined for only for specific products. Then we can have a separate database for cart, a separate database for checkout. That means they all are working separately. They are not dependent on a single resource. And the idea behind microservice is that some type of applications becomes easier to build and maintain when they are broken down into smaller pieces which work together. That's the main idea. And it becomes much easier to do the entire maintenance, patching up the servers, taking care of, you can say, applying any maintenance window or upgrading the servers as and when required. And that is the main concept of using microservices, especially for these large retail stores. Just like we have a separate microservice containing the catalog server and the database, same way for shopping cart and database, and this for checkout server and its own database. So each of these microservices could be scaled up in its own container if required without disturbing the others. That's the main concept of using microservices here. And using Docker Compose, we can connect all the isolated containers as a single service. So basically, Compose makes sure that, suppose if we want to start the application, right? So we don't need to go individually in each and every service component. For example, here, we don't have to go to each and every service and then start them manually. Because if we have 15 different microservices deployed for a single application, and then starting, stopping, or managing each and every service manually is not going to be an easy task, correct? So using Docker Compose, we can connect all the microservices together, and then we can start them, we can manage them easily using a centralized location, or we can say as a centralized service. And that is a main advantage of using Docker Compose, where we can use all the services, we can start, stop, we can deploy all the services at once by using this Docker Compose section. So now let's discuss what exactly Docker Compose is. So Compose is basically used for managing all the containers together, and it allows us to make sure that we are having the centralized management tool to manage all the containers in case you want to apply some configuration changes on multiple components of these microservices. And that is exactly what Docker Compose is. So basically, in simple layman terms, we can say it is used for running multiple containers as a single service. And each of the containers here run in isolation, but they can interact with each other whenever required. And Docker Compose files are very easy to write in a scripting language called as YAML, which is a XML-based language that can be used easily without having any kind of parenthesis or complex syntaxes required. The entire layout is much easier for the Docker Compose files as they are written in YAML. And another advantage that we get by using Docker Compose is that users can activate all the services using a single command. So if you want to stop all the microservices, we can do that. If you want to activate all the services by using a single command, we can do that easily by using Docker Compose files. Now, a simple example can be, for example, if we have an application that requires an engine server and a Redis database. So we can create a Docker Compose file that can run both the containers as a service without the need to start each one separately. We can do that. And there are multiple advantages that we get with Docker Compose. So basically here, if we talk about Docker Compose, then it offers a single host deployment. That means we can run everything on a single piece of hardware. We don't need to have multiple hardwares for running the entire environment. And it is quick and easy to configure as well. It offers a high level of security. That means all the containers are completely isolated. When we say they are able to communicate with each other, that doesn't mean that we are compromising the security. They are still completely isolated from each other. And then it simply reduces the entire threat landscape here. And it offers easier configuration due to the YAML scripting, which is much easier to structure. Even for those who are not proficient in the coding aspects, they can still make use of YAML script for configuring the entire containers in an easier manner by using Docker Compose. And then it also offers a high level of feasibility, and again it offers a high level of productivity. So basically it reduces the time it requires to perform the task, and thus increasing the entire level of productivity that we can achieve from this entire Docker Compose tool. So what is a compose file? So compose file, as we have seen, it's simply written in YAML script. So basically, when we are creating a YAML script, we again define the entire versions, as in the version of the file, the services that we are going to work with. Like we have the database. So here we can choose the image as Postgre. Here we can choose define the environment as in the Postgre database, the user, the password for the current environment that we are working with. And then for web services, we can define the entire build command, whatever command we want to be executed for the current web version. Then we can define the volume, the ports, depends upon the entire configuration that needs to be done for the web servers. So that's why we can define the entire services. And we have microservices. Then we can manage these services individually by defining the service properties. And here we can notice there are no parentheses required. There are no semicolons towards the end. And that makes the entire deployment of this compose file much easier because it is based on simple YAML script. And the compose file is basically a YAML file definition service in networks and volume. The default path for compose file is .docker and -compose.yaml. So this is basically the default path for Docker file. Although if we want, we can customize that. But again, in case we want to maintain the homogeneity of the file structure, it is recommended to make sure we are keeping the default path the same. And it contains a service definition which configures each container started for that particular service. So now let's see how we can install Docker Compose in our system. So first of all, the process of installation is going to be a bit different based on the platforms that we are going to choose. So as a part of a hands-on, we are going to work on Ubuntu platform, which has been deployed on a cloud service by AWS. So based on the platform you're going to use, suppose if you're going to install this on a Windows server, on a Linux server, and that too based on your own system, that's going to be a bit different. So I'll be guiding you all on how we can take care of different installations. But for our hands-on, we are going to make use of the Ubuntu server running on as a part of EC2 instance service offered by AWS Cloud Platform. So first of all, to get started, we have to use a simple basic command in Linux. So first of all, we have to deploy the EC2 instance, and then we can get connected to that server by using PuTTY or using any other SSH client. And then we can start by using the pip library for installing Docker Compose in our system that we want to use as a part of Docker Compose file. So on Linux system, first of all, we have to install Docker engine for the operating system, and then we are going to use pip library and then install Docker Compose to install Docker Compose on a system, and then we are going to use Docker Compose version to verify if it has been installed properly or not. Because if it's not properly installed, then we are not going to see the Docker Compose version returned to us. So let's see how we can install Docker on Ubuntu platform. So currently what we have done here, we have an EC2 instance running on top of the Ubuntu image, and we are going to install Docker Compose on this particular server. So basically there are some prerequisites that needs to be installed and configured on the server before we can start with installation of Docker Compose. We do need to have the entire pip package. We need to have the entire Docker engine already installed and configured. And for getting details on how we can install these different Docker engines, so you can find the references to install these different packages and how to configure them as a step-by-step guide in the description below. So we are going to use the pip library that we have already configured on this entire Docker engine. So we are going to use a common command as sudo pip install Docker Compose. And once we are done with installation, then we are going to check for the version and see if the correct version has been installed or not. Because if we are not getting the version returned, then that means there is some error and we have to do the installation again. So to make things comfortable for you all, so that you don't have to strain your eyes, let's increase the font size. So we can go to configuration. Currently, we are using MobileStem as our SSH client. We can use any of the other SSH client. It is not mandatory to use only a single platform. Depending upon your comfort level, you can use any of the SSH client as per the comfort level. So let's increase the font size from 10 to, let's say we increase it to 16. Let's restart the instance. Now we can clear the screen. Now here we are going to work on installation of this Docker Compose file. So first of all, we have to use a command set as sudo. Then we are going to use a pip library. And here we are going to define install docker-compose. So this is going to refer to the pip package manager we have already defined. And then it is going to refer to this package and download the entire Docker Compose library for us. So as you can see, the entire package has been downloaded. And to make sure that the entire package has been correctly installed, we can refer to Docker, Compose, and version, because again, this is going to make sure that we are having the right version installed. And if there is not installed, then again, we are going to see an error. That means the current version has not been installed properly. So I hope this entire installation process is clear for everyone. So we have to use a command as docker pip, and there may be some different versions of pip you may have installed. For example, if you are using pip 2 or pip 3, then you have to maintain the version there, and then docker-compose, and then this is going to install the entire package. And to cross-check if the Docker Compose has been properly installed or not, we can use docker-compose space -version, and that is going to return the version of Docker Compose that has been configured. So we had seen how we can install Docker Compose. Now next we are going to see a Docker Compose hands-on. So in this hands-on, we are going to deploy a microservice. So basically here we are going to deploy a Docker Compose project, which contains a Docker file where we have the entire Docker file defined in the same format as the template that we have seen earlier. So we are going to define a version, the services, which we are going to deploy, both in terms of database and the web services. And then we are going to create a Django project by building the image from the build context defined previously that we have seen. So let's see how we can define that. And towards the end, we are going to see how we can set up a database connection to this Django platform. Docker Compose, then we are going to work on our Docker Compose file. First of all, here we are going to create the entire configuration files. So here we can create a separate project directory, which is going to be our project directory where we can name the directory something easier for us to remember. And this directory is meant for creating the image that we are going to use as a part of our Docker Compose tool. So directory can be anything. We can name the directory as per our own requirement. We can name it as anything. And here we can define a directory by the name of sudo mkdir for making directory. Let's say we made the directory name as Django. Now we already have the directory name defined as Django apps. So basically, if we want to create a new directory, we can define it as any name. And we already have defined a directory by the name of Django apps. So we can switch to the directory. For example, say we want to switch to the directory, here we can define the name as Django-app. And in here, we are going to create 3 main files that we are going to work with our Docker Compose. So first file we are going to work is Docker file, which is basically the file that is used to create the image. So for creating the Docker file, we can use any of the editors. We can use vEditor, we can use Nano Editor, whatever editor we are comfortable with. Let's say we can make use of Nano Editor. Now, basically, when we are creating a file, we should be giving the sudo as in the admin privileges. So we can define sudo, and then we can define the editor name as Nano Editor, and then we can define the name of the file. Now, when we are creating a Docker file, we don't have to define any extension. So Docker file doesn't have any extension, so we don't need to write any extension in the beginning or towards the end as well. It is simple, plain Docker file. So here we have defined the Docker file where we are going to define from the library as Python for version 3. And then we are going to define the environment on Python buffered. We are keeping the value to 1. And currently we are defining the run command here from the main directory where we have stored the entire code. So basically Docker file will contain, is going to define the entire application image where we are going to run multiple build commands that is going to configure the image itself. And then we are going to define the work directory where exactly we want to copy the current requirement text. So requirement text is going to contain the entire dependencies that needs to be configured, right? So basically this file is used as a part of the Docker file itself. And in requirement.txt, we are going to define the Django version and the binary package that we are going to create separately. So here we define the file name as requirements.txt that we are going to create. And then we are going to define the run command that is going to be executed when once we are creating the image. Again, this entire command is going to be executed from the pip library. We are going to install the parameters that we are going to define in requirements.txt file, and then we are going to copy it in the default location of the code. So this is what needs to be there in our Docker file as a part of our hands-on. Now to save this Docker file, we have to simply press Control X, and then it is going to ask for a confirmation that if we want to overwrite any of the file, then we can press Shift yes and to overwrite the current file. Once we are done, then this is going to be saved. And after creating this Docker file, just to make sure that we are done with Docker file creation, whatever we have entered has been saved correctly, we can again open up the Nano Editor, and here we can see the entire code being visible to us again. So that is going to make sure that the entire code has been successfully updated. So to close this, we can again press Control X in case we are using the Windows system, or in case we are using the Mac, we can use Command X. So we can press the Control X statement, and that is going to simply bring us out of the Nano Editor. So now once we are done creating the Docker file, then we are going to create a requirements.txt folder or text file in the same project folder. We don't have to change the path. We have to create a requirements.txt in the same project directory. So for again creating the file, we can again type the same command as sudo. We can use Nano Editor. We can define the name as requirements.txt. So we have to make sure that there is no typos in this requirements file. And once we enter, we can see that file that we have created where we had defined the Django version. and then the binary package that we want to define in this particular requirements file. Because again, at the end, Docker is going to install the requirements that we have specified in this Docker file. So whatever path we have given there, we have defined the path as requirements.txt, right? That's why the name of the file also needs to be the same. And here, when the requirements.txt file is going to be installed, then again, these Django with the specific version is going to be installed and configured on the server. So we are going to come out of this. Same way we can press Ctrl X, and just to be sure that the current file has been updated, we can again run the same command. So for reusing the same command, we can press the upward arrow key, and then the last use command is going to be repeated. So again, just to cross check that we do have the content saved in requirements.txt, we can see the commands being opened up, and then we can come out of it by pressing Ctrl X again. All right, so now once we have Docker file, once we have requirements.txt configured, then we are going to create docker compose.yaml file in the same project directory. So basically, as we discussed, docker compose.yaml file is going to describe all the services that we are going to use for making the application. And as a part of a hands-on, we are going to use the servers for web servers and database, as we have seen previously. So the compose file is also going to describe which Docker image these services use and how they are linked together, and any value that may need to be mounted inside the given containers. And then that's why we are going to deploy this kind of Docker compose YAML file. So basically, we can also define all the ports. That means which ports to expose as a part of configuration that we can define under docker compose.yaml. So let's create that. So again, we can do the same thing. We can run the same command as sudo nano, and here we can define docker compose.yaml. So YAML format is basically either by AML, or as a standard, we can keep it to YAML format. So here we can define docker compose.yaml. We can press enter. So this is the Docker compose file that we have to create, where we have to define the version to be kept as 3. Under services, we have defined database. The image is going to be Postgre. In case we want to use some other database engine, then we can define it. For our hands-on, we are going to make use of the Postgre itself. So here we can define the database, the name of database, the user, the password that needs to be configured, because at the end, we don't want to do this manually. That's why we are taking the help of this Docker compose file. And here we can define the configuration that needs to be done for the web servers, the build, the command that is going to be used for Python manage.py. And then we are going to run the server, localhost, and that too on port 8000. So again, we can define the entire volume that needs to be configured, the port that we are going to use the port 8000, and it is going to depend upon the database that we have defined here. So name has to be the same, because if there is any misconfiguration, then our database in our application is not going to get connected to this database that we deployed. All right, so same way, if you want to save this up, we can hit Ctrl+X, and then we can define the yes format to make sure a Docker compose file is created. Again, just to cross check that if we do have the content updated there, so we can simply use the same command set as sudo nano docker compose or YAML to see if the content has been correctly updated. And then we are going to work on the Django project. So for working on Django, we can come out to our root directory, and then we are going to create the Django project by running the docker compose run command as per the current structure defined. All right, so now we are going to work on the Django project first. So we are going to build the Django project. Now here we are not going to discuss the entire Django project in detail, because our main focus is to see how we can make use of Docker Compose to deploy the components of Django application and how we can manage it, right? So we are going to use the project that we have already configured locally, and then we are going to simply import that project and configure it by using the Docker Compose YAML file that we have created. So let's do that. So basically, for getting started, we have to make use of this command as sudo docker compose run web Django admin start project compose example dot. So basically, this is going to instruct compose to run Django admin start project compose example in a container itself. And this is going to be done by using the web service image and configuration Now, because we know that the web image has not been deployed yet, correct? That's why the compose is going to build it from the current directory as specified by the build command that we have defined as build.line, and that has been mentioned in the docker compose.yaml file. And once the entire web service image is going to be built, the compose is going to run it and perform the entire execution for Django admin start project command specified in the container. And the command is going to instruct Django to create a set of files and directories representing a Django project. Now, currently what we have done here, we have installed the entire Django project. And basically here we have defined the Django project from the entire container. So now once the entire web services has been built, now, as we know here, currently we are working on the entire Docker part, right? Now the files for Django admin has been created, or there's going to be defined here, owned by the root user, because in that container runs as a root user itself. And for changing the ownership, we can define the sudo change ownership, and we can change the ownership back to the root user itself. So let's do that. Now for changing the ownership, we can execute the command set as ch owners. Basically here using the admin privileges of sudo, we can use the ch owner for changing the ownership, and then we are changing the ownership back to the user. Now, this has to be defined here. For example, currently, if we have connected via Ubuntu, because currently we are using with the platform for EC2, where we have connected by the name of Ubuntu user itself, right? So here we can change the username, define. Currently, we are running Docker. So suppose if we are using this entire setup on your Mac or Windows, then we should have the ownership of all the files, which includes the files that are created by Django admin. Now, to see the list of the files, we can simply use the ls-l command to see the entire list of all the files that has been generated. And for seeing the entire ownership of all those files, we can simply use a command as ls, and then we will be able to see the list of all the files along with the ownership that has been defined by using the command as ls space -l, especially when we are using the Windows or the Linux systems. And now we are going to connect to the database. Now in this section, we are going to connect the database server with the Django application that we deployed. And in the project directory, we have to simply edit the settings.py file. So where we are going to replace the entire credentials for the current database that we have defined. So let's do that. So for editing the file here, again, we can make use of the same nano editor. Depending upon whichever editor we are comfortable with, we can make use of V editors or nano editor depending upon the requirement. And here we have to specify the path for compose example, because that is what we have created. And then we can define the file path as settings.py. Here we have to open this settings.py file. Now this contains the entire default configuration that is going to be used by the Django application. So when we are defining the entire security component, we have to make sure that we are going to allow the host to all or to specific IP of the server that we want to allow the access to. So basically in production servers, we don't keep it to all, but again, as a part of a hands-on to see this up and running, we have defined this to all. So all we can define by default, the file is going to have no values defined. So we have to add this asterisk value under single quotes that is going to give the access to all the hosts that on which we want to access Django application. Then we can scroll down and we have to locate the section for database. So basically in database, we'll be having the default parameters defined, where we have to configure this based on the application and based on the Docker file that we have created. So this is going to be the engine that we have used for Postgre. Then we have to define the name, username, password that we have used, the host, that is the DB that we have created while we were working on the Docker Compose file. And this is a port on which we have opened this database engine on. And once we are done defining all of these attributes, we can save this file and then we can come out of it. Again, just to cross check if we have defined the same file, always have a cross check, because again, it is a common issue that sometimes we may forget to save the file even after writing all the changes. So that's to make sure we have all the changes defined. We can again open the same nano editor. We can cross check for all the components. We have allowed the host and the database configuration is also defined. So once we are done, we can come out by pressing Control X. And at the end, now we have to run the command as sudo docker-compose up. So basically, this is going to simply turn on the entire Docker Compose section, which is currently going to launch the application so that we can make use of it. So once we have this one deployed, then we can come to the browser. If we are deploying this on a local machine, then we can simply choose any browser on which we want to open the application. For example, we can come to the browser and we have to type in localhost. In case we are deploying this on a local machine, we can type localhost, and then we had to install the application on port 8000. So here we can define the port number, and this is going to open the application in the browser. Like we can see here, this is a default Django application that we have successfully deployed by using Docker Compose. And if we are deploying this on any of the cloud platforms, and as we had defined the host to all, so we can specify the IP of that particular instance that we deploy, and then we can add the port as 8000. So this is going to open the application in the browser. And now if we want to customize it further, we can easily do all the customization as per the requirement. All right, so to see how exactly we can stop the application, so we can come back to the console. Now, first of all, easiest method is to simply kill off the application by simply pressing Control C, and this is going to simply kill off the application right away, as in a force stop. So although this is quicker, but again, this is not recommended when we want to stop the application. So if we want to stop the application, then we can use a simple command called as Docker Compose down. Just like we have used Docker Compose up, so we can use Docker Compose down. Basically, it's a more elegant way to shut down, which basically switches to a different shell and run Docker Compose down from the top level of our project directory itself. Let's say once we have the application up and running, let's say we run the application again. Now, if you want to stop the application, we have the application up and running, we can simply use a command such as Docker Compose down. So to summarize, in this entire video, we had seen what exactly Docker is, how it is structured, how it is used by majority of the DevOps engineers, why it is popular, and then we had discussed why we have to use Docker Compose, how it helps us in managing the microservices for any application. If we have an application divided into multiple microservices, then how we can manage them easily by using Docker Compose, which allows us to start and stop the services at once and manage them as per the requirement. Then we had discussed on the complete architecture for Docker Compose, how it is structured, how we can create a Docker Compose structure, how we can install Docker Compose, and then we had seen how we can deploy a sample Django application by using Docker Compose, by installing all the dependencies, and how we can start the application and how we can stop the application once we are done with our hands-on. So that's it for this entire session, guys. And thank you so much for watching the video.